Hello and welcome to this interview called Journey into Success. I am Professor Jagdish Tonannavar, Chief Editor of Spring Chronicle, an online platform for publishing scholarly articles. For more, please visit springchronicle.org. This interview is being hosted by S&S Knowledge Partners, Bengaluru. My today's guest is Professor Ravi Korisettar, an internationally acknowledged geoarchaeologist who is known for seminal works in his field as well as for saving the most ancient Neolithic sites in the district of Ballari, Karnataka state. Why these sites are important? According to Professor Korisettar, I quote, "These sites are of substantial importance to our understanding not only of South Indian society and culture, but also at a more general level, the processes that led to village life and megalith building in numerous instances across the world, and thus they merit protection at the international level." Today, I will discuss the outcomes of some of his most impactful excavations, their findings, significance, and more. I must introduce Professor Ravi Korisettar that he is currently Adjunct Professor at the National Institute of Advanced Studies, Bengaluru, and is also the founder and honorary director of Robert Bruce Foote Sangankallu Archaeological Museum, Ballari, Karnataka state. He has many achievements to his credit, fellowships and honors. Among them, he has been conferred Dr. Vishnu Sridhar Wakankar Rashtriya Puratattva Samman for the year 2018-19. Last year, Government of Karnataka awarded him Karnataka Rajyotsava Prashasti, and this year he has been the recipient of Adim Kalaratna National Award. He has written many books and edited, among them, The Indians, Histories of a Civilization with Ganesh Devi and Tony Joseph, Beyond Stones and More Stones in 3 volumes, Indian Archaeology in Retrospect in 2 volumes, and currently excavations at Sangankallu, which is in press. He has delivered several talks across India and also abroad, and premier institutions include University of Cambridge, Harvard University, Smithsonian Institute, George Washington University, and more. With this brief introduction, I invite Professor Ravi Korisettar to this interview.
Thank you, Professor Jagdish.
Very warm welcome to this interview.
Thank you once again.
And we thank you very much for your time.
I must thank you more than you thanking me, because you thought of me as one suitable candidate for this interview. Until now, I didn't know that I was one of the achievers. And many thanks for this kind of recognition.
Yes.
It is much more valuable than the kind of awards you mentioned that have
Very
received.
kind of you.
Yes.
Yeah. Professor, now we begin our interview. Of the many research findings which you have contributed to the resolution of long-standing issues related to chronology, origins, and development of early cultures in southern India in general, and North Karnataka and western Andhra Pradesh in particular. Now, for the benefit of our viewers, now may I ask you the following questions one by one.
Yes.
In the year 1987, you discovered volcanic ash in the Kukri River Valley in upland Maharashtra, and it made media headlines. What is the significance of the discovery?
Yeah, thank you for this very, very important question. For a very, very long time, Indian archaeology was suffering from lack of absolute chronology for early human settlements. And as you mentioned, prior to coming to Karnataka University and occupying a position as a faculty member in the Department of History and Archaeology, my first appointment immediately after my PhD was at the Physical Research Laboratory in Ahmedabad. I, as a postdoctoral fellow and also an associate of the project, was involved in paleoclimate studies of Kashmir Kareba sediments. So my PhD was an interdisciplinary topic called Geoarchaeology of the Middle Krishna River in Karnataka and so on, wherein I had field training both in archaeological fieldwork as well as what we call quaternary geological fieldwork. So this had made me competent to handle two disciplines, especially in field. So what happened after my PhD, there was a post advertised by the Physical Research Laboratory, which you may be knowing. It was founded by Vikram Sarabhai, and later it was mentored by, famous advisor to our Prime Minister Indira Gandhi, Menon. And then Professor D. Lal was a pioneer in radiometric dating and establishing the radiocarbon dating laboratory in TIFR, Bombay. So after Menon was shifted to Delhi, Lal was asked to take over the Physical Research Laboratory and its development. So he, along with his entire staff, moved from TIFR, Bombay to PRL in Ahmedabad. So that is where there was a separate area for which was established as a national facility for dating archaeological sites, especially radiocarbon. After it moved to Ahmedabad, he started exploring other ways of establishing dating laboratories, Precambrian dating, quaternary dating, and things like that. So I was a candidate for that post in that multidisciplinary project, and the entire panel of nearly 8 members who fired series of questions to test my ability to answer interdisciplinary questions. I literally lost. I was lost in the interview, but I thought I may not be selected, which I was sure because my degree was in archaeology, not in any field of science like geochemistry or physics or chemistry as such. But somehow the panel found me suitable, and I started working for the project. And my field area was Kashmir, mapping geological formations covering the last several million years. And there also the major problem was without a chronological control, any reconstruction of the past events has no standing at all. So we were looking for dating material, dating horizons, or sediments which help us establish an absolute chronology. And so by then, the study of what we call volcanic ashes had picked up in the Sivaliks, sub-Himalayas, and then similar deposits were also anticipated in the intermountain valley of Kashmir. So there were competing geologists, institutions from the US and also India working in the same area and looking for this kind of material called volcanic ash, or it is generally called tephra. So in the context of older sediments, these are already altered. So they are called tufaceous beds. And then identifying them in the geological sequence was very, very challenging task. So that is where I was very keen on looking for such a sediment, which is called a chronometer for geochronology. It is also called a marker bed in geology because you can tie up sections, river sections in different areas, into a composite, lithologue. So that chronology was even more important. We knew that they are post-orogenic, post-Himalayan uplift. These sediments were filling up in the Kashmir Valley as well as in the sub-Himalayas and so on. So I was, obsessed with that particular thing. But we gradually, during the course of our fieldwork, we noticed the presence of volcanic ash, but it was bentonitized. They're called bentonites, which contain, elements or particles from the ash in a secondary context. Yet they will give us a hang of the chronology. So we found it. Some experience I had, but after a couple of years of working with the Physical Research Laboratory, I returned to Deccan College, Pune, as a postdoctoral fellow. And until '89, I happened to be in Deccan College working on different projects and so on. And then when I was there, prior to coming to Deccan College, I used to survey and look at kind of strange sediments exposed by the rivers. It was not deliberate, but sometimes when you notice something unusual, you always want to see what it is exactly by closely examining the sediment and so on. So we were on a period we were surveying that river Kukudi, and then it's a basaltic terrain, entire western Maharashtra, including northern parts of Karnataka. Basalts are basic volcanic rocks, whereas these volcanic ashes are acidic in nature. So there is a difference, big difference in chemical composition of these two materials. Extrusive volcanoes, but the products are from a different source. So we were surveying, we went to visit a Paleolithic site. Instead of going in the downstream direction, we were walking in the upstream direction. That was a kind of a blessing in disguise. I was also accompanied by a eminent geologist from University of Delhi, and we were walking together because he was the one who had selected me for the job in PRL. And then we were walking and looking at the sections, and here far off on the other side of the river, I saw a strange material sitting very prominently. I told him, Professor Tandon, please wait, I'll just come back. So went on to the crossed over the river and touched the material, and it turned out to be volcanic ash. And that was a red letter day in the history of quaternary geochronology of fluvial sediments anywhere in southern India. And then nobody could believe me that in a basaltic terrain one can expect a kind of thing called volcanic material, volcanic ash. This area was active, volcanically active some 60 to 70 million years ago. So it was a very quiet geological terrain. So this was a bolt from the blue. Even other geologists who were with me, they couldn't believe that it is volcanic. So we collected samples, went back to lab department in Pune, and then examined under the microscope. It turned out pure volcanic glass. So that is syngenetic. Along with the eruption, the glass is generated, and this is a pure glass. It is a nascent glass, and it contains our potassium as one of the radioactive potassium 40 radioactive element. So there is now fresh accumulation of potassium 40 when it settles into a geological environment. So that is where potassium 40 begins to disintegrate. So when we found this particular material, we were all excited, but we could not believe ourselves. And then what happened when it was subject to dating by potassium organ dating method, it turned out to be 1.3 million years old. But that was an anomaly. Chronologically, it was an anomaly because the sedimentary sequence was very, very thin. In all over South India, the sediments exposed by the rivers are all very thin, about 5 meters maximum. If you go to sub-Himalayas and the central Himalayas, they run into several kilometers. Like, for example, Karavas were 2.5 kilometers, which I mapped single-handed, working in the interior parts of the Kashmir Valley, very high altitude regions of Kashmir lakes like Margs and so on. So this was an anomalous date, and we began to debate among ourselves. But till then, we did not have an absolute, time marker for the sediments exposed by the rivers. So this date, of course, for the first time gave a date, but that was a chronometric revolution in southern Indian quaternary geoarchaeology. So quaternary refers to last 2.6 million years and so on. So that led to series of debates. Then we started submitting papers to Nature elsewhere, and then inadequacy of data. And then we could not. I mean, since it was a joint authored paper, we had to compromise at some point. So they wanted to establish, yes, we do have 1.3 million year old volcanic ash in the Western Deccan and so on. But we were sure that it is not the correct date and so on, because Professor Tandon and myself were more arguing against accepting that date. And then papers were turned on, and then we pursued our analysis of the material. We did electron microprobe analysis. I collaborated with John Westgate, a specialist, world renowned tephrochronologist. So he specialized in fission track dating, organ dating, potassium organ, and then single crystal organ 40 dating, and all these methods he had mastered himself. So he established, I shared the sample with him. we met at one INCOA conference, International Quaternary Association, met in Beijing in 1992, 91. And I shared my samples with him. He processed them and gave an age of 74,000 years. So where was 1.3 and where is 74,000 years? So this was acceptable to us because at 74,000 years ago, there was this volcanic eruption in Sumatra, which is known as Sumatra Toba caldera, where the eruption had taken place. And that was the high magnitude eruption, 28 million cubic meters of volcanic ash was thrown into the atmosphere. It was transported across southern Asia, global south, what we generally call, and it reached the East African lakes. It went into Pacific Ocean. It is found in the Arabian Sea, Bay of Bengal, Indian Ocean, bottom course, and so on. And then this map microprobe fingerprinting established the fact that yes, it matches very well with 74,000 year volcanic ash and so on. Till then, we were only guessing the age of archaeological material from these fluvial deposits or riverine deposits and so on. And then we thought we should look for similar things because it was a shock to the entire geological community in India because they had missed, seeing that and identifying that. So they launched a massive hunt for volcanic ash across India, from Narmada in the central India to Kanyakumari and so on. They began to find everywhere. So all over South India. So they were joking, Ravi's ash is spread all over India, kind of a thing. So that is where it began, and the chronology which was missing for Paleolithic in India began to now take a firm basis. And then onwards we started, of course, in the last 30, 35, 40 years, many new methods are available. We don't necessarily need the presence of a volcanic ash material, but we have other methods called optically stimulated luminescence, thermoluminescence, and now AMS radiocarbon dating. They have a different, time depth in terms of going back in time. So we are in a comfortable position, but this set in motion what we call chronometric revolution in the Paleolithic archaeology of India. This short question, a long answer.
Very nice. So, if I have understood you correctly, this ash, this came from Indonesia?
Yes, Sumatra Island.
Sumatra. That's a paper you have published in Science. Right?
Yes, the science paper is it belongs to evidence from much later, research which we carried out in Andhra Pradesh. But this first paper, which carried electron microprobe analysis and then fixing the age at 74,000 years, was published in what you call quaternary research. This is the top class, journal, Q1 journal in that area, quaternary studies. So if you have a paper in quaternary research, you have a paper in Nature otherwise. Yeah.
My next question is, your work on the Malaprabha Valley in Kaladgi Basin, which is known for a dense occurrence of Paleolithic sites in the northern region of Karnataka, has shed some light on new understanding associated with geomorphic and man-land relationship. Could you briefly explain this?
Yeah, after I joined Karnataka University, I had to find a fertile ground for carrying on my research interests. And my training, as you know now, in very multidisciplinary areas, I thought that having seen volcanic ash in an unknown area, in a misfit geological basin, why not near home? We have these river valleys where a lot of archaeological research, especially Paleolithic archaeological research, was carried out since about 1870s or so. The sites have been very well documented. It comes from a rocky terrain. And if we have a chance, we may be in for surprises, and then we may be able to have new insights into the chronology of, the human occupation in this area. And then one of my friends who sort of an admirer at that point of time, because while I was working in Pune, Deccan College on these volcanic ash, American scholars used to come there and they saw my work, and then they were very keen that they should continue to work with me. But they knew that I was struggling for a job permanent job. I was on temporary project, jobs till then. So when they came to know that I am now based firmly in Harvard, they said, Ravi, why not we work together, and I will bring money. You lead us in the field, things like that. That worked very well for me because, funding for, university researchers, especially in history, archaeology, is not very encouraging. So I said, yes, most welcome. And then we started off revisiting the sites which were documented since 1870s. These sites were first reported by Robert Brucewood, the same name we have given to our museum in Bellary. He is called the father of Indian prehistory. And then in 1940s, Professor R.V. Joshi, he was the founder of the Department of Geology at Karnataka University. Later, he moved to Archaeological Survey of India. He was geologist, like quaternary geologist. So he had published his research jointly with Karnataka University and the institutional collaboration in publication was going on very strongly. The 1940s, when since as long as Dr. Pavate was vice chancellor and so on.